Hey, all my JavaScript friends, this is the Virtuoid, aka Mike Smith, and this is Fun with JavaScript, our racing game. We are now to the point in our video series where the four wheels that we've created in our last video, and that's these four wheels right here, will actually be distributed to look like the wheels on a car. And what we're going to be doing here is we're going to be creating what I call a wheel base and using what they call hinge joints, or what FWJS calls hinge joints, to be able to join the wheels to the wheelbase and basically allow the wheels to turn while keeping a steady distance from the wheelbase itself. So basically the wheelbase kind of, if you think of it, kind of acts like an axle, and the undercarriage of the car kind of holds everything together while the wheels turn. Let's take a look at that diagram that I created for the last video, the really bad looking one. Our wheelbase is going to be that white dot in the middle. And of course the little ellipses represent the four wheels. And the joints are represented by the four lines that you see connecting from the white dot in the middle to the four different wheels. And again, these joints, and they're called hinge joints, allow the wheel again to turn while keeping a steady distance from the wheelbase itself. So the wheelbase is going to be responsible for holding all four of those wheels in place while they do their thing and turn on the ground. So let's go ahead and let's put that code into action. Okay, so the first thing that I did is I've defined the defaults for my wheelbase. As you can tell, it's extremely small, depth of 0.1, width of 0.5, and height of 0.5. I've given it a very heavy mass here. This is one of those variables I'm actually playing around with. I'm not sure if this mass number belongs here or on the big chassis that we'll be building a little bit later on. But for right now, I'm just going to keep what I know works within my program, within my proof of concept. So that's the wheelbase right there. Let's add in some more code. Let's just go down here. We can add this in without copy and pasting. This is going to be wheelbase. There's our private variable. So do we need to put anything inside the constructor? Yes, we do. Let's do that next. And so we added something inside the constructor. Now earlier, this part was not in my original POC, so we're going to move that down to here. Say wheelbase restitution, and let's go back up to the top here and add a restitution to wheelbase up here. Restitution of, we'll make that 0, just like we did with the wheel itself. Okay, so that initializes the defaults for the particular car there. All right, the next thing we're going to do here is we're going to start with the build section to actually do the operations to actually build out the wheelbase. And so what I did is I created a specialized routine that does nothing but the wheelbase itself. That's let wheelbase equals this private method add wheelbase. Let me go ahead and cross this out. We don't need that anymore since we get that information there. So this, we're going to say let wheelbase is equal to add the wheelbase. This is still where we're creating the wheels. Now, when we set the physics, that's where we're going to set the actual joints. So we need to pass wheelbase to set physics and return wheelbase from set physics. And when we get to set physics, we'll do that. So we've got that all set up, and then we need to save it to our variable. I can't type within the class. Okay, that should take care of everything that we had on the build. We're going to need to obviously have the add wheelbase. So let's pop that particular code in. Oh, and by the way, again, I meant to say that you can find this on the GitHub repository that's listed below, but it's going to be under the release/0.0.3 branch. That's what I'm working off of here. And I meant to mention that at the very beginning, forgot to mention, so I'm mentioning it right now. But anyway, we have add the wheelbase here, and this is basically creating just a simple little box. And there's the clone. We're going to change it from false to true so we can actually see it on the screen itself. But the whole purpose of the wheelbase is, again, to basically give us an anchor point to be able to anchor the joints for all the four wheels so that they remain in place at all times. So they just don't go wandering all over, the wheels don't go wandering all over the place, but they are still allowed to roll. So we got the wheelbase there. Now, this is where the fun part comes in. This is what everybody's been waiting for. This is the set physics section. So the first thing we're going to do, we will be passing wheelbase to the set physics. and we will be returning it. So let's go ahead and add that in to each one, to the arguments and to the return statement. Okay, so right now all we have is just the wheels itself. So let's go ahead and first of all create the physics imposter for the wheelbase. There's the wheelbase physics imposter. And again, the physics imposter in this case, notice that we do have we're using a physics imposter for cylinder imposter. That actually should be a box imposter because we're creating a box up here, as you can see right here. But for some reason, and I honestly don't know why, I've got it. This is one of those things that, maybe over, Christmas break or something, I can take a look at this and really delve down exactly why things are happening. But for some reason, the cylinder imposter worked better than the box imposter. Go figure. All right, we're missing a couple of variables: wheelbase friction, and restitution. Restitution is set for 0. We really don't want a restitution of 0. That's going to be wheelbase restitution. Hope I spelled that right. So we're going to need to add those variables, and that we can get those from the arguments at the very top. Notice here, earlier I said in the last video, I did this on purpose because we'll be adding things like the chassis and the wheelbase and all that kind of fun stuff. Well, that's just the reason why we're adding the wheelbase too, is that the default wheels and the default wheelbase each have mass, friction, restitution, all that kind of fun stuff. In fact, let's go ahead and add restitution in here. I can't spell restitution. Here we go. That should be wheelbase restitution. Ta-da! Okay, thank you IDE for telling me I did something wrong. So this is, again, since we have the same variable names within the configuration files up here, this allows me to be able to rename them as they come in. So mass now gets renamed to wheelbase mass, and friction gets renamed to wheelbase friction, and restitution gets renamed to wheelbase restitution. Now that we got the physics imposter for the wheelbase, let's just go ahead and run it. Let's see if we get any kind of errors or anything. So we run it, and there we go. The 4 wheels have done nothing. And oh, hey, there goes our there goes our wheelbase. There we go. That's one of the things that you have with a cylinder that it does. It does that and everything. But as you can tell, nothing's been connected up to the wheelbase itself. That's our next step. This is now going to be the magic. It's called a joint. So let me just pop that code in there real quick. And that is here within the for each loop of the wheel. All right, let's see. It says I'm missing the import statement, so let's do the import statement. All right, so what do we got here? All right, so a hinge joint, again, basically says that I've got a particular joint, or I'm going to be defining a particular joint here that basically says I have one mesh that will be connected to another mesh by some form or fashion that will allow one mesh to move while the other mesh does not. Why they call it a hinge joint, I have absolutely no idea. In fact, they have one called a wheel joint, but it doesn't work with ammo. They had another one called a hinge 2 joint, but it doesn't really work with ammo very well. It just didn't work with what I had here. Hinge joint worked great. Why, I don't know. Again, during Christmas break, that's something I might be able to really delve into. And of course, if y'all want to delve into this and try to figure out what's going on, leave a comment below. Honestly, everybody learns better if everybody shares information. But anyway, doesn't really matter. The key here is this main pivot. And this basically says, okay, I've got in this case, my wheelbase, and how far away do I want to, from the perspective of the wheelbase, how far away is the joint for this particular, or the pivot point for this particular hinge joint? This is where, if we go right back to the very top here, last video where we defined wheel parameters, this is where this pivot number comes in. And I said, hey, pivot number will come into the next video when we do joints. Well, now it's here. So the pivot number is basically saying, okay, I'm going to have the right front a certain distance away, the right rear a certain distance away, the left front a certain distance away, and the left rear a certain distance away. And so this will now allow me to have the wheel base say, okay, I've got a joint for this wheel, for this other wheel, and for these other 2 wheels here, and they're going to be at these particular positions. So that's what the joint defines here. I've got a new hinge joint at this particular pivot point. And that pivot point, where is that pivot point coming from? Well, that pivot point is coming from somewhere. Oh, there it is. I couldn't find it there for a second. I knew it was here somewhere. Line 116. That's where we're getting the pivot point from that wheel data that I showed you earlier. So that's basically what it does. And so to actually make the connection, we go to the wheel physics imposter on the wheelbase and we say add joint. And we ask what joint is, or what is the mesh that we're going to be adding to the joint. And it's going to be the wheel that we just got finished defining here. And what is the joint? And that's the joint. So I mean, you can have multiple type joints if you wish to. I mean, you can have multiple types of joints, or hinge joints on this one, another kind of joint on this one, another kind of joint, whatever. And you can add multiple joints to different wheelbases. So what I've done here is I've got a single wheelbase, and for each one of the wheels, as it is on line 115 there, I'm going to create a new joint, and I'm going to attach that wheel to that joint. And each one is going to get a different pivot number based upon whether it is right front, right rear, left front, or left rear. And that should be able to separate them. That should be able to separate them into different places, and and that will attach it to the wheelbase. And once we're done with all 4 wheels, we return the wheelbase. So once we return the wheelbase, that will get us back up to the build, and we save the wheelbase. That should be all there is to it. So now we get to find, we'll go to the browser here. Now we get to find out whether I've made a typing error, if I've forgotten something here, but that should technically be it. So let's just go to the browser. And let's hit a refresh there so you can see it better in action. And oh, there we go. There it is. So right there in the middle, I got my cursor on it. You can see that's our wheelbase. Those are our 4 wheels. And there it goes. So as you can tell now that the 4 wheels are now physically connected to the wheelbase itself by these invisible joints. And they're at the right position, and they are rolling down our slope here. Really nice. So what I want to do here, just so we can kind of see how everything looks a little bit better, is let's take the rotation off of the ground. Just so it kind of stay on the screen just a little bit longer. There it is. Now, I have determined, once it does hit the ground, it still has a little bit of momentum going for it, which is, of course, the way it is, And so slowly but surely, it will eventually get off the screen itself. So notice the wheels are very big and they're very round. So let's make a couple of changes here. First of all, the scaling factor. Remember we talked about the scaling factor in our last video, and this allows me to basically, if I have larger tracks or smaller tracks, be able to scale the cars themselves. I looked at my code. Earlier, last video, I said I think the scaling factor, which I've defined right here, was 0.35. It wasn't. It was actually 0.25. So let's save it as 0.25. And this is a better size of what our car is supposed to look like. And let's just, whoa, there we go. Kind of see what's going on there. There we go. Okay. So that's what our car actually looks like. So what is there to change? Well, the first thing to change is, take a look at this. Notice how it just kind of twirls around. And it took me a long time to figure out why the heck is it twirling around. Well, the reason it's twirling around is that these are round balls for the wheels. Okay? Earlier, I had tested, when I was trying to do all this testing, and I finally got this part working after a lot of heartache. When I finally got this part working here, one of the things I noticed is that with the round wheels, it can also slide sideways or roll sideways if the track happened to send it along that way. Right now, it's just going back toward the back. That wasn't good. We needed to be able to not have it slide sideways. Cars just don't slide sideways. So I made these into cylinders. Well, they work great as long as it's going forward, but the second it tried to go left or right, it just stopped in its tracks because the cylinder had a hard edge on the side. Well, tires don't have hard edges. They got very small, but they got kind of rounded edges. So that kind of allows them kind of cheat a little bit to the side. So how did we fix that? Well, this is how I fixed it. Basically what I did, let's go back to the car base, is earlier what we did is that when we added the wheel, we created a sphere. Well, I still create a sphere, but when we create a sphere, it actually allows us to be able to create spheres with different diameters. So, you might have a diameter on the x-axis, you might have a certain diameter on the y-axis, you might have a certain diameter on the z-axis. So let's pop some code inside there, and let's go to let wheel. Let's just comment that out so we can keep an eye, we can see what it is. So nothing's changed here. I'm still creating a sphere, but I'm giving it a different diameter. Notice the diameter of X is the same, the diameter of my Y is the same, but my diameter, excuse me, my X is the same and the Z is the same, but the Y is now half the size of what the diameter is. What's that going to create? That should create an ellipse. So now that we saved that, let's go to here. And there we are. In fact, let me see if we zoom in a little bit here. Oops. Okay, I'm just kind of getting to where we can kind of see what it looks like. So now the wheels look like that. And they look a heck of a lot better too now. Oh, there they go, they're rolling off. Ah! And so what I discovered is that they still roll perfectly good forward. They do resist rolling sideways, but they will roll a little bit sideways. So you get some skidding and everything like that, which is what you normally get with cars, especially these kind of cars, which obviously we don't have steering wheels or anything like that on them. So those are the wheels. Now, and that's pretty much it. We've got the physics, I'm sorry, not the physics, excuse me. We've got the wheelbase in the middle that is basically anchoring the four wheels. And I found out later the wheelbase actually will anchor the entire car. It worked out great that way. So, and then it goes, off it goes. Let's refresh again. So we've got that. We've got the four wheels. They are proportioned, at least the way I want them to be proportioned, correctly on that one. So let's do a couple more things here. First of all, are they actually turning? I mean, we can see this, but one of the things I also ran into earlier was that things were more sliding than were turning. And I thought, yeah, that's just obviously it's not, you want your tires to turn. So let's see if we can get those tires to actually turn. And what we're going to do is I found some material. This is something I've not really done a whole lot with, here we go. Okay, let's import. We're missing some imports here, but this is basically a way to be able to skin a mesh. I've created what's called a standard material, and then I added a texture into that material. And this particular texture I'm just grabbing off the internet. It's a PNG file. I just grabbed a random thing off the internet that I could try to find that allowed me to be able to, at least see some demarcations within the tire. It doesn't even look like a tire, but that's not the purpose. The whole purpose of this is to make sure it actually spins, as you'll see here in just a second. So I've created material, or I created material to the wheel itself, and then inside the material I've set the texture to this particular texture. And now this will set the same texture all four different wheels so that we hopefully will see them spinning. Well, let's just save it. Let's go here. And there we go. And you can see there are kind of different textures there. Back up just a little more, and you can see they're rolling. So this proves that they are actually rolling. Let's put our ground rotation back on. See what happens. Yeah, it rolls off immediately. There we go! Yay! Yep, there we go. Beautiful, beautiful, beautiful. Oh, crash. That happens every once in a while because the ground is very thin itself. So notice it kind of bounced a little bit once it hit the ground there. So I don't know why exactly it does that, but every once in a blue moon it does do that. Every once in a blue moon, like for instance, the wheel base will get stuck underneath the ground, so everything just kind of stops and does absolutely nothing. So let's just do a refresh here. And there we go. That's the whole idea here now, is that, hey, I've got I now have my four wheels. I have a wheel base, and that wheel base through the joints are all connected up at a certain pivot, or set the pivot point a certain distance away from the wheelbase itself. And that gives me my four tires. That they are now all interlocked within that joint. They're allowed to spin as they normally would, and it works great. Now, as you can tell, there's still a couple of issues with it. As you can tell, it kind of broke through the ground a little bit. It still slides a little bit more than it really should have. So there's things are not quite fully fleshed out yet. Especially once you get working with the track and everything. When we do the track, you'll see that in particular really prevalent. that there's still a couple of issues here. But like I said, this is a proof of concept. I encourage you to please take the code, figure out, see if you can improve upon it. And if you can't improve upon it, let everybody know, add a comment, do a pull request. Heck, if it's great, boo, crash. Do a pull request, and if it's great, I'll add it. I'll add it in. Wouldn't bother me at all. So that's pretty much it for the hinge joints. Our next video, we're going to actually start building the bodies to the cars. That's going to be a relatively short video. And then our last video on the car, we're going to actually add models, and that's going to be the really fun part. If you like this video, please click on the like button below, subscribe to this channel, or leave a comment. I'd love to hear from you. We are trying to reach 1 million subscribers by February of 2042, and we really need your help with that. Again, thank you so very much for watching. This is the Virtuoid, aka Mike Smith. We'll see you later.